Alright, so let's go ahead and graph this part now. Graph f of x equals negative cosine pi over 4. I'm going to have the period. So I have 2 pi over b. Class, what's my b value? So again, write this right above it so you can see it. Your b value is pi over 4. So I'm going to have 2 pi divided by pi over 4. I'm going to make that 2 pi times 4 over pi. So I'm just taking reciprocal now. Notice how your pi's will cancel, and you're left with 2 times 4, which is 8. My period is 8. You should be using a straight edge. You'll be marked off on points, be considered messy. The reason why is you're not attending to precision. And I have 8 here. Class, what's half of 8? 4. So again, if you're doing the same idea, just multiplying out there. This gives me 4. And then half of 4 is... And then 2 plus 4 gives us 6. That's 0. So I'm going to write down my x values now. So I have a graph up here, and I'm down here I'm going to use a table. 0, 2, 4, 6, 8. Now I'm going to do cosine at pi over 4 x. Class, do I have cosine? Did I say sine?
The negative.
Oh, we're going to get to the negative. So cosine of pi over 4x. Class, do I have to worry about that pi over 4? No, you've already dealt with it based on these numbers here. Okay? So cosine is going around on the quadrantals, or your unit circle, is what? 1, 0. Okay. A common mistake is to write 0, 1, negative 1. 0, 1, negative 1. 0. No, sorry. A common mistake is actually to use sign. 0, 1, 0, negative 1, 0. So just pay attention to which trig function you're using, and if you ever get stuck, just draw yourself one, and then you can use the quadrantal angles. Alright, now I'm going to draw another line. And now we're going to have the negative sign. Now this negative sign is like an a value of negative 1. So negative 1 times the cosine of pi over 4x. So all I have to do is now multiply my function, which I've done previously, by negative 1. Negative 1, 0, 1, 0, and negative 1. I'm going to go ahead and graph that. And I want to show you guys the parent function, so let me graph this one in yellow. This would be 1, 0, negative 1, 0, and 8, 1. So my parent function will look like this. And what this negative 1 does is you'll see that it reflects over the x-axis. Each point is being reflected. So let me show you guys a mirror. You'll notice that 1, and then in the mirror, goes down to negative 1. But here at the x-axis, a point on the x-axis, there is no reflection. So what's the hint? When you see the negative on the outside, class, where's the negative? It's going to be reflecting over the x-axis. If there was a negative inside, like a b value, it reflects over the y-axis. You can have that in your notes if you don't have it. So let's go ahead and graph this one now. So I have -1, 0, +1, 0, and -1. This is what our new function looks like. Remember, you will be deducted points if it is a sharp point, because you're basically kind of showing me it's an absolute value that is incorrect. You don't need to graph the parent function, but it helps you kind of make sure you're understanding how we get those points. And this is what your graph looks like. Let's show you how to use it on a calculator. I have a calculator here. Class, are these in degrees or radians? Do you see that? I have radians, so I'm going to put my calculator into radian mode. Common mistakes that students don't have on their calculators: if you have stat plots, second y equals, make sure your stat plots are all off. So y equals, I'm going to clear out, just write that in. Remember, this is the negative sign. This is a subtraction sign, so we're talking about negative cosine. And then it tells me pi divided by 4. Your pi button here in blue, so you're going to have to press the blue button first. Now, if I press zoom, and I go down to number 7, it says zoom to trig. So it's actually going to give you the quadrantals here. Let's see what happened. The reason why I graphed a constant, because I'm like, I was wrong. I forgot my x. Let's make sure we're really clear on that. Second insert parentheses. Let's say divided by, not divided by. Let's try that again. Negative cosine. You can also have this as, do you guys see that, how it's over 1, so you can have pi times x? Let's do that. Pi divided times x. Let's do an extra parentheses just in case. X divided by 4. Now you can do zoom 7. Now remember, this could be kind of confusing because if I restrict my domain, you can actually think right there, pretty close to that, or something like this. What does that look like? Oh, you can't see because of my reflection. What graph does that look like? It actually looks like sine. Okay? So here, ours looks a little bit different because you're like, Mr. Ng, this goes through the x-axis or intercept through that point. You might be asking how come that doesn't do that. It's because on zoom trig, you're actually at the quadrantals. So that's pi over 2, pi, 3 pi over 2, and then 2 pi. So if I change my window, if you want to get it exactly like ours, okay, my x values are basically 0 to 8. And then we're counting by what? 2. You can see here they were counting by pi over 2. My y minimum is a -1. My max is 1. Graph. Wish I had the same exact graph because it basically shows what we got here. Alright, the worst thing you can do on graphing trig functions by hand is putting it into your calculator and copying the calculator. That's the worst thing you can do. Okay? So we are graphing those by hand. Your calculator, the technology enhances your learning by showing us in different ways that you know how to graph.